So Unit 11, we're starting up on something called conics. Conics are basically a variety of shapes. We're going to be talking about 4 conics in this unit. Today we're going to talk about circles. It just says distance and midpoint, but we really will be talking about circles also today. Another thing we'll be talking about, another conic, is parabolas. We'll start those up next class. We've already talked about parabolas. We're going to get a little bit more information about them next time. And then we're also going to learn about ellipses, which you might call an oval. And then lastly, we're going to learn about these guys, which are called hyperbolas. So they just kind of keep going like that forever. So those are conics, and today we're going to be focusing on circles. But first we're going to review what midpoint formula is and the distance formula. This is what we call coordinate geometry. It's geometry involving shapes, right? That is in the x and y plane with, points and whatnot. So we're going to talk about the midpoint formula and distance formula first. All right. You don't have to write this, but I like to go over, before I show you the midpoint formula, how to get the midpoint formula, because I think that knowing how to get that formula will help you remember it better. So before I do that, though, does anybody remember what the midpoint formula is? No. Well, let's see. Let's go ahead and derive it. You guys might notice I have this solid black line here. This is a line, right? And we have 2 endpoints, x1 and y1. And I want to find the midpoint, which should be somewhere right about here, right? How can I find the coordinates for that point? That's the question. Well, it's kind of hard to find the middle of a diagonal line. Now, if it was like a horizontal line, we just count the squares and find the middle one, right? On the grid lines. But it's not horizontal, it's diagonal, so you can't really count squares. But here's what we can do. I want you guys to notice something kind of interesting. If I take this point here and drop straight down, what do you notice about that point right there on that other dotted line that I drew at the bottom? It's right in the middle, right, of that dotted line. And if I go straight across, I get the middle of that dotted line, right? So those are horizontal and vertical lines, aren't they? And those are nice and easy to find the middle of. Now we're going to do some algebra here. I'm going to make you think for a second. Can somebody come up with the coordinates of this bottom right-hand point? You're not going to have numbers, okay? But it's going to involve using these other 2 endpoints. So I'm asking you guys, can you come up with the coordinates for that bottom right-hand corner? It is going to be an x and a y, but like I said, you're going to be using these also, those specific points. We're going to be using those, yeah, but it's not x1 and y1. That would be that same exact point, right? Maybe. Let me help you out a little bit. This point, it's the same height off of the x-axis as what other point? This one, right? So you agree that this point and this point have the same height off of the base, right? Off of the ground here. What letter here represents the height of that point? The y. So this point over here has to have the same y value. So it's y1. Now, what point has the same x value as this one? In other words, it's the same distance from the y-axis. The one right above it, right? x2 has the same distance from the y-axis. So this one has to have the same x2 value. So this would be the point here, the coordinates would be x2, y1. So why did I do that? Well, I want to find the middle of that line. Now, if there were numbers there, we would just count it, right, and find the middle. But think back to statistics. How do we find the middle of some set of numbers? You could do it that way, but like counting from each end until you get to the middle. That's like the mode, or no, I'm sorry, the median method, right? But we don't have numbers to actually count here. So what other way can we find the middle? You're getting warm. Find the average, right? Doesn't the average represent the middle? So this horizontal line goes from x1 to x2. So to find the middle of that line, we're going to average x1 and x2. What would that look like? x1 plus x2 equals, or I'm sorry, and we do what to it? Divide by how many there are. There's 2. So the coordinates of that midpoint of the dotted line there would be x1, x2. And we can do the same thing for this one, only we're looking at the y values because it's going up and down. So this is the highest point, this is the lowest point. And if we average those, y2 plus y1 divided by 2, you'll get dead smack in the middle. Now, why did I want to find the middle of these dotted lines? Well, because when I put those together, we get the middle of the solid line. So we don't have to have question marks there anymore. We can actually say what the midpoint is. The midpoint is x1 plus x2 over 2 for the x value, and y1 plus y2 over 2. And that's the midpoint formula. Now, just to make it easy for you guys to remember now, instead of trying to memorize that formula, can you guys memorize this? The midpoint is the average of the x's and the average of the y's. I think that'll help you remember it a little bit better than trying to memorize those numbers. But in case you want to write it down, here it is. Go ahead and put that in your notes with the title. Okay. Let's go ahead and do some example problems here. Go ahead and write down your directions in number 1. So we learned what the midpoint formula was. This problem is asking for the midpoint of each segment whose endpoints are given below. So these are endpoints here. It starts at 1, 3 and it ends at 2, 5. Our job is to find the middle point, the point that would be right between those. Yeah, we can get fractions. So, well, we talked about in the last slide, to find the midpoint, you average the x's, you average the y's. So what are my x's? 1 and 2. So to average those, you just add them together and divide by how many there are, which would be 3 halves, right? Let's take a look. So now we're going to average the y's, right? So 3 and 5 are my y's. If we average those, we get 8 over 2, which is 4. And there's your midpoint. Alright. Now you don't have to do this, what I'm about ready to do, but I just thought I'd show you what we're doing. Here's the endpoint, 1, 3, and 2, 5. Let's find those. Alright, so 1, 3 would be over 1 up 3. And then 2, 5 would be over 2 up 5. And if I graph this, where should I expect my midpoint to be? Well, let me ask you this. Would it make sense if when I plotted my midpoint it'd be over here? No, where should it be? It should be right in between these, right? Let's see if that's true. I got 3 halves, which is 1 1/2. So I'm going to go over 1 1/2 and then up 4. And there it is. Pretty darn close. So that's a good way to check your work. You don't have to graph it, but I just thought I'd show you guys what we're actually finding. All right, go ahead and write down number 2, please. So I just thought I'd include one more example so you guys can watch me work with some negatives here. So the x values in this case are -3 and 4. So we have -3 plus 4 divided by 2. And that would give me, let's see, -3 plus 4 is 1. Divided by 2 is 1/2. And then the y values are -1 and -2. If you add a -1 and a -2, you get -3 halves. So there's your midpoint of those 2 points.